Hola, buenas. Hoy vamos a presentar una presentación de cómo introducir inteligencia artificial en vuestras aplicaciones móviles. Espero que os guste. Just kidding. This topic can be complex enough to talk about it in English, so I won't attempt to do it in Spanish. Apologies to our Spanish speakers in the audience. Hi, everyone. My name is Sachin. I'm a product manager on the Firebase team, and I work on ML Kit. And here is my colleague, Ibrahim. And today, we are going to show you how you can introduce machine learning into your applications to make them more powerful and create great experiences for your users. But before we do that, Ibrahim, why don't you tell us what machine learning is?
¿Cómo? Yeah. Oh, okay. I thought for a second Sachin decided to go off the script in Spanish, and my Spanish is not as good as him. So I'm Ibrahim Ulukaya from the Firebase team, and today we'll talk about what machine learning is and how ML Kit makes it easy for you to implement in your app. And we'll go through a few real-life examples. Should we get started? Let's roll. So what is machine learning? By definition, machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. So what do we mean by that? Traditionally, software development is implementing rules. Let's say we have this app, and we are detecting activities. So we have the speed sensor data. We can say if the speed is below a certain threshold, this is walking. And we go one step further. We do another if and else statement, and we get to running. And if we go even faster, maybe we can estimate as biking. But I just realized that Sachin put another thing on my app, on my slides. And he likes golfing. But how we go through detecting golfing, just getting the speed is not going to be enough anymore. And in this case, we need a different type of programming. In the traditional programming, we have already rules set. So we'll get the data, and we'll get the answers. But in machine learning, we don't have the exact set of rules yet. So we'll need some of the previous answers to get the rules first. In machine learning, we will need models and training data. So we'll need some of those answers, some labels. We'll need to teach our computer how walking looks like or how biking looks like. Let's say we have like labels and we have a different set of sensors. Could be a visual sensor data. And we can say this is what walking looks like. Then we start training our neural network, saying this is running looks like, this is biking, and this is how golfing looks like. So machine learning has two phases. The first phase, we have the previous answers, we created the model. Now we have the model. We can go through and create predictions with the data we have. So how does it work? Let's say we have a digit recognition. For us, we can detect that this is 8. But it's a quite intensive step for our eyes and brain. And for computers, maybe we can estimate is a traditional programming. We can say for 8, it is 2 loops on top of each other. But is that easy? Let's say we have this example of 28 by 28 pixel, which would give us 784 inputs. And if we use these inputs as zeros or ones or filled or empty pixels, then we can start training our neural network, and we will end up in neurons that should give us answers at the end. Here, there's one of the neural network in action. We are actually converging to a model that we can finally detect different digits. Up until now, software development has been all about adding another if and else statement, and we were just using the input data to generate outputs. Here, we cannot explicitly set the rules anymore. We need to train our neural network, tell the machine, this is what this digit looks like. So how about the steps to implement machine learning? Historically, this was a big deal, involving ML experts, lots of time, and money. A data scientist would collect a training data set. Usually, ML experts or PhD researchers have to develop the model. The expert would then train, evaluate the model, and tune as needed. Finally, once the model is ready, we have to deploy the model to our systems. The DevOps would do that. And after all these steps, finally the developers can start predicting, can use this model to predict. This is a quite extensive stage. That's how we end up with MLKit. MLKit is Google's machine learning SDK for mobile. With using MLKit, we can simply skip all the stages I mentioned earlier, come up with just inputting our data to our libraries, and come up with the prediction. And it can be all done by the developer. By using the base API, it's as simple as selecting the model you need. They work both in iOS and Android devices, and we will have actually cloud APIs as well as on-device APIs. If you are an advanced user, you can still use the MLKit to host your models. And it's only a few lines of code to implement. For now, currently we have vision APIs such as barcode scanning, face detection, image labeling, text recognition, object detection, all out of the box. And we have natural language APIs such as language identification, smart replies, conversational smart reply, on-device translation. And if you want to bring your own model, your custom model, we will help you serve it as well. If you're an advanced ML developer and you brought your own model, you don't need to republish your app every time you update your model. If you update your model, you want to implement a new one, you don't have to go back to store and wait for approval. You can just update your model on the fly. Today, I want to present a real-life problem. Let's say we have this app. It could be a financial app or a bank app. Let's say we want to submit a valid form of ID. And we realize that often people don't submit the right type of document. And we'd like to catch that in the earlier process. Let's go from the simplest solution first. Let's say we want to recognize the text in the ID, so we can come up with some solution. Say that if it's verified ID or not the right ID. We have two flavors of the text recognition API. The on-device API is completely free, while the cloud API is free up to 1,000 API calls per feature per month. While the on-device API is perfect for low latency, such as real-time applications, it does not require network. The cloud API has a higher accuracy recognition. The on-device API is good for sparse text and images. It can recognize Latin characters, while the cloud API also works with densely spaced text, and it recognizes a broad range of languages and special characters. I would like to go for a demo. So let's go for the valid identification. Let's see first use the real-time application. A text detection, and we'll go for one of the IDs we have here. I'm using the on-device API. As we can see, I'm detecting the names, addresses, the other things in the ID. But if we want to get like a higher accuracy of resolution, or we want to use it in dense text, we can also use the cloud API, such as I can detect one of the things I just found, the scavenger hunt. Let's take a photo of it, and we'll use the cloud API. Here, okay, I got lucky here. So we have the detection results. We have a much better detection, higher accuracy, and we were able to work in the denser text space. So this was only text recognition. What if there's like different pictures on the ID, and also we want to see how an ID might look like? We also have the image labeling API. Maybe I can give it a try on that as well. So let's take the picture of the ID here. And we will use the image labeling here on device one. And I thought it was news. But I think we're not going to get there quite yet. So having said that, I want to give it to Sachin, hand over to Sachin, who will go over the more advanced solution.
Which one is it?
Yeah, this one.
All right, thanks, Ibrahim. OK, can we switch back to slides? So like Ibrahim said, what we want to do here is we want to, let's think back of the problem. We want to identify what type of document we are dealing with, right? So that before a user submits it in the application, we can tell them, yes, it's a driver's license, or no, it looks like it's a business card. The image labeling API is generally good for identifying objects. On device, it identifies 400 different types of labels. In the cloud-based version of the same API, it identifies 10,000 different objects. Let's see what the on-device would say for something like this. For Ibrahim, it said news. When I tried it, it said paper, poster, smile, all things that are valid. But they're not really useful for my use case. So what do we need? What we need is a custom model for our application, for our use case, that can identify the things that we want. Traditionally, you could always create your own custom model in TensorFlow and TensorFlow Lite. But if you don't have any machine learning expertise and you don't want to write a single line of code, we have AutoML Vision Edge. AutoML Vision actually launched last year, and there was a cloud-based version of it. So like Ibrahim explained earlier, when you're creating a machine learning model, there are two steps. You train the model, and then you use the model. The AutoML Vision Edge product that we launched this year allows you to train the model in the cloud, but then the model runs fully on device. So once the model is actually in the application, you don't need an internet connection. You can just start using it. OK, so how does it work? Going back to the steps of building a custom image classification model, traditionally you would have to prepare the training data, develop the model, you train it, tune it. Once you're satisfied with that, that takes a little bit of time. You do a lot of iterations. And then you deploy it, and then you use it. With AutoML Vision Edge, you still need to bring the training data, because that's how you're teaching the model, right? You have different classes of objects, and then you bring that data. But the next step is just to give it to AutoML Vision with an ML kit, and it will take your images, it will train the model, it will tune it, evaluate it, and deploy it for you, and leave it ready to be used. So for our particular example, what we're going to do is we're going to take images of driver's licenses, business cards, and then other random images, because we realize that a lot of times when you ask people to submit a picture of a document, they'll just point somewhere and take a picture, and we want to catch that as well. Those images then go to the AutoML service, and what you get as an output is a TensorFlow Lite model that's ready to use on device. OK, so let's see it in the console. Switch back to the laptop. OK, great. So I'm in the Firebase console, and I go to the MLKit section, and then I click on AutoML. The first thing that I'm going to do is I'm going to add a data set. So I'm going to call it license. And here's where you choose whether your data set has single labels or multi-labels. So that means a single image can be one thing, or it can be more than one thing. In our example, it's just simple, right? We have 3 labels, so it's a single label classification. And once the data set has been created, the next step is to upload the images. And you do that. You can do it in a zip format if you want. And the way the zip is constructed is it's 3 different folders. Each folder is labeled by the thing it has. So I have a folder for driver's license, another one for business cards, and another one for other. And I zip all of that together, and then I upload it. OK, so this is going to take a little bit to upload. So I'm going to show a data set that I uploaded earlier. And this has images from all those 3 categories. You can see that they are labeled. In this browser, I can switch the label of the images. I can add more images if I want. You can see that there's a warning here. And that's because while AutoML Vision Edge will work with as little as, or as few as 10 images, we recommend that you have at least 100. And really, for a good machine learning model, a lot of training data is key. But it will work, so we'll do it for this example. The next step is to train the model. Here, I have 2 choices to make. The first one is the architecture of the model that I want to choose. I can choose one that's higher accuracy, but it's going to be slightly slower, more latency, because you can imagine, right? It's a model with more layers, more complex, so the data takes a little bit longer to pass through. It's also a little bigger, but that's the way to do it with higher accuracy. If you care about lowest latency, you want a response really quick. In this case, it's 22 milliseconds versus 105 milliseconds. You would choose the lowest latency. And of course, you have a choice in between as well if you want something that's between the two. The next thing you would do is you would choose the number of hours you want to train the model for. The way I like to explain this is, imagine that you are studying and you have a page, right? You can probably learn the page in a minute. If you have 10 pages or a book, it's going to take you longer. Similarly, with machine learning models, depending on how big the data set is, you need more or less time to train. The good news is that this is an upper bound. So if you say you select 8 hours and the model just optimizes and learns quickly and it's done, it will stop training and it will be ready for you to use. Okay. So here I would click Start Training, and that would take a few hours. So I'm just going to jump to a model that's already been trained. And here we can see the precision, the recall, and the expected latency of this model. You can also see a confusion matrix, which basically says, in the test part of the data set, every time we gave it a business card, how did it perform? So it says that it confused it with other a few times. That gives you an idea about where your model is getting confused and where you should introduce more data. So you potentially want to add more business cards and more other images so the model learns how to differentiate between the two. So these numbers are actually not very realistic because I had a very small data set, but it gives you an idea of how it works. Once the model is ready, you can test it within the console. You can upload an image and it will tell you what it thinks it is, so that's a good way to test it without implementing it in your app. Now notice, we've created a model here and we haven't written a single line of code. And we don't even need machine learning experience, right? Okay, so now that we have the model, what do? We have to use the model, and here we have two options. The first option is to download the model and bundle it with my app at build time, so it's ready when the application is installed. The other option is for me to publish the model on Google's infrastructure. The benefit of publishing is that if you choose not to bundle it with your app, the initial install size is smaller because the model is not there. Also, when you publish the model, you can, because it's in the cloud and it gets downloaded dynamically to the device, you can swap it whenever needed. And we'll go through an example of that. So let's say if I have a model and then I've improved it with more data, I can then switch to a different model and I don't have to redeploy my app. Okay, so let's go back to the slides. So let's say we want to publish a model. And by the way, the recommended way to do it is that you do both, right? You download the model so it's ready to use when the app is installed, and you also publish it so you can swap it. So let's say that I publish it and I give it a name. I call it license model. So then I'm going to configure the labeler, I'm going to load the model, and then I'm going to pass the image to the labeler that I've created. Then I have on success listener, on failure, and then on success I get all the labels. And then I can start extracting them and see what the predicted labels are for that image. Okay, so let's do a quick demo. Switch to the, okay. All right, so let me point it to a driver's license. And you can see it says driver's license. And then let me point it to a business card. And it says business card. Okay, great. So back to the slides. There were two APIs at use. You saw the first thing that happens was that we created a bounding box around the image, and that's the object detection and tracking API. It's a base API ready for you to use. And then we took the cropped image, passed it to the AutoML model, and it predicted what it was. One quick thing to point out, just because this model was really easy to create, it doesn't mean that it's a toy model, it's not good. It's actually state-of-the-art. They're 1.8 times faster than the state-of-the-art handcrafted MobileNet V2 models. And those are difficult models to create. There are many possibilities, design is challenging, and there's a lot of iteration involved. Here you just upload the images and you get a model. Okay, so what if I want to add a new type of document? Let's say we bring our application to Spain. And here, we have driver's license, business card, and other, but maybe we also want to start detecting passports as an additional type of document. It's not a problem. We add an additional class of images to our data set called passport. We pass that to our AutoML Vision Edge. It generates a new model for us, TensorFlow Lite, ready to use on device. Okay, so now I have 2 models. What do? Do I just switch it in production? That's the kind of thing I like to do, but I don't think it's recommended. So you can deploy multiple models with remote config. Remember, we published our initial model and we gave it a name, license model. And in the code in the application, we would hard code the model name. We would say license model, and that would retrieve that model from the cloud. Okay, so now what I do is I publish a second model, which I created with the passport pictures, and call it license model ES for Spain. Then I create a remote config parameter. Remote config is a service within Firebase that allows you to create dynamic parameters that you can then switch on the fly or switch depending on the audience. So in this case, I'm creating a parameter called my model. And for users in Spain, they're going to get the value license model ES. Everybody else is going to get license model. So and the condition called Spain is going to be triggered if the user is in the country Spain. In our application, instead of hard coding license model as the string, I'm going to switch it to the remote config parameter. This is what makes it get the right value for that specific user. License model ES if it's a Spanish or user in Spain, and license model otherwise. Okay, so that's how we implement a model, an AutoML model in our application. There's still a part that's a little tricky here to do. How do I get the training data? Creating the model is easy, but how do I get the training data? We actually ran into a similar issue when we were implementing our application. So we created an open source app called Custom Image Classifier. And what it allows you to do is within the app, you can create a data set. So let's say it's for fruit, for example, and I add a bunch of labels. Next, I can start collecting samples. So in this, my example would be driver's licenses, right? I actually went and took pictures of driver's licenses. Here's an example of collecting a picture of an apple. I can even take a short video, which allows me to pan around it really easily and get a lot of different angles. Not only that, but you can collaborate with others. So I can invite Ibrahim to my project, and he can add apples that he has at home, because maybe my apples are red, his are green. And we want to train a model really well. We need a lot of variety in our data. So then once we've done collecting the images, we can go back to the console and start training the model there, or we can trigger model training from within the application. Once the model is ready, we can take a picture of another apple, for example, and see how well it does. So you can do everything from collecting the data to training and testing the model, all within a single app, open source. So we really encourage you to play with it, download it. It's available for you to download. Okay, so to recap, MLKit makes machine learning really easy for you to use. It offers ready-to-use pre-trained models that we call base APIs. In the vision section, we have landmark detection, barcode scanning, face detection, image labeling and text recognition, which Ibrahim demoed, object detection and tracking, which was the bounding box that I showed you in the AutoML example. This year, we also launched a few examples with natural language. Those are language identification, smart reply, and on-device translation. And then, for those with custom needs, you can always bring your own custom model, and you can host it with MLKit, and we'll serve it to your end users. And if you need help in creating your custom image classification models, you can do so with AutoML Vision Edge. That's all we have for you today. We can't wait for you to try all this functionality and give us feedback. We'll be outside waiting for the Ask Firebase session if you have any questions. Thank you very much.
Okay.